morning. I think a couple of people won't be joining us today, Yuri and Steve, but any comments on the feedback price and where did people end up, or what they've seen since the competition ended?
Yeah, so I'll go first. I finished quite far down the leaderboard in the end. My best score was, and let me see. Yes, my best private score was 0.65. In the end. No, sorry. Yeah, well, 0.649. Yeah. Yeah, so I just want to mention that in the end, I found one of the things I found was using an extra loss function for classifying the discourse type. It helped most in my case. Yeah. In terms of
that's interesting. So,
yeah,
but tokenization-wise,
sorry.
So tokenization-wise, you just did the standard token type and then essay text added at the end kind of thing, but added an additional loss to predict the discourse type. Is that what I heard?
Yeah. So yeah, it's very simple. So if I show you my final sort of selected models, you can kind of see that these ones that end up around here, above 0.7, they are all sort of just using a single loss, and these ones down here was using the extra loss. So basically, I include the extra loss function, and then I do a weighted average of the effectiveness loss and the type loss. And with these ones, so I give a weight. So for these ones above 0.7, the weight for the effective loss is 0.8. So that means 0.2 for the type loss. But with these ones, so the weights are 0.6, 0.4. So when you give more weight to the type loss, the best metric you get is lower than 0.7. That's kind of what I discovered. I mean, that's the thing that most helped me in my case. All the other tricks, I can't really say.
Yeah, that seems to suggest that at least for the model, and what kind of what model is it? A DiBerta, just standard DiBerta model that you're using?
Yeah, so most of these are so this is a base. This is a small. No, this one. The blue one is small, and this is a base.
And
yeah,
the
so
one that
even yeah.
The one that
so
you
even
have
if you
at
use,
the bottom is the base, or
yeah, base. I couldn't. Yeah, I couldn't get the large to train nicely. I didn't have enough time in the end to get it to train nicely, so I kind of just gave up on that. So the best model was a DiBerta base trained by giving a 0.4 or 40% weight to the type loss. And yeah, everything else was
And
very
did
simple.
you make any modifications at the top of the deburter model, or is it a standard deburter model? Did you add any kind of head or
yeah,
mods?
so I used so I used self-attention pooling layer, and then for the effectiveness and type predictions, I just used a single dense layer. So really nothing fancy there, I think. Right. Yeah, and also I discovered that so I was monitoring like the performance for different discourse types, right? And so you can see like, just scroll down here. So there are seven types of discourses, right? And so I encoded them as in the following order. So type 0, type 1, type 2, type 3, and so on. And I was monitoring the performance for each of these types. And what I noticed was that like for many of these types, right, you can see like the best score is kind of the same, right? But if you notice for type 6 and type 2, when I'm using that, when I give that extra weight to the type loss, the performance improves quite a lot in these two types. So it's type 2 and type 6. And if we come back here, and if we look at type 2, so type 2 is counterclaim, and type 6 is rebuttal. And if we look at like the number of samples, like in this histogram here, you can see that they happen to be like the two types with the least number of samples. And so maybe the improvement that results from having the type loss, well, it comes from, it happens for types that are underrepresented. And so this reminds me of what Ato suggested, like maybe like if you train 7 models, like you might actually get an improvement as well. Like maybe you get like a good performance in all the different discourse types. Yeah.
Yeah, I was about to say that even the fact that in this fascinating stuff that you've seen, and in fact, the thing there that from what you shared, it seems like if the model is made to predict an unlikely or less likely type, then by recognizing that it is of the unlikely type, which the model does because you have provided it a loss for that particular purpose, it seems to be able to do better on the related task of efficiency prediction, right? Which what you're observing that.
Yeah, that's kind of my thinking. Yeah, it's quite. Yeah, it's kind of interesting
because it predicts a hard to predict discourse type or a less frequent discourse type, then somehow it's able therefore to also do a better job on the effectiveness, which, again, there were charts similar to what you showed of the distribution of effectiveness per discourse type, which was there in one of the EDAs. And
right.
we just looked at that. then at least initially you wouldn't think that because the distribution of effectiveness, if I recall, you know, did not vary depending on the discourse type. You know what I'm saying? Like you have the distribution here of discourse type, and of course, the largest number are claims and evidence, and the least are, as you shared, counterclaim and rebuttal. The interesting thing is to look at the effectiveness distribution, that is the distribution of ineffective, effective, and adequate for a discourse type. And if you looked at that, and I think it was there in that PDA, whatever, that long notebook. And if you looked at that, you know, counter to what empirically you have shown, it didn't seem from that chart that or I should say it this way, that the distribution of the effectiveness pretty much is similar for each of the discourse types. So you wouldn't think from that, you know, there is basically a difference in the effectiveness distribution conditioned on the discourse type. But on the other hand, what, you know, your results indicate is that may be true, but if somehow the model is made to learn and predict the discourse type, it seems to help predicting.
Yeah, I guess
it helps the model get better at predicting the effectiveness. Sorry, you were saying?
So I guess what motivated me to include the extra loss was before, if I was using a single loss effectively, I noticed that type 2 and type 6 had like relatively poor performance compared to all the other types, because if you look at here, this is like the best you get is 0.7, and here the best you get is actually above 0.8. So I kind of just say, okay, so what is type 2 and type 6? So I looked at this histogram and said, okay, type 2 and type 6 are these two. And I just thought like, oh, maybe it's because they are these two types are underrepresented. So maybe if I ask the model to try to identify these two types, then maybe it might help. I mean, at that time, I was thinking of just training 7 models, but I decided it was more simple to just add an extra loss. And then it just so happens that after doing that, the performance for these two types improved. And yeah, so it was just kind of trying things out, really. Yeah, that's kind of all I've learned in this competition.
Yeah, I submitted and I kind of, in fact, interestingly, you know, I tried multiple things, as I was saying last time, combination and fumble. So this was, in your case, just a single model with 2 losses, a debutter base, and how many folds did you use? Or
sorry, yeah. So the graphs I've just shown you, they're all for just a single model, single fold. But for the submission, I did you know, ensemble a couple of those lines in the graph I showed you to get a better score. Yeah.
And each of them were about 3 or 5 folds.
No, they were just like single fold, single model. So when I do an ensemble, I never use all the folds. You know, say you have like a debutter base and debutter small, and I have 4 folds for each. I never ensemble all 8 available folds because, well, I mean, I never have the time to join all of them. Yeah, so I just kind of select like, 2, 3 of these model and folds to ensemble. Yeah.
Oh, I see. So you're just ensembling the best 2 or 3.
Yeah. Oh,
Yeah,
another
so in
thing I
my case,
tried was, yeah, sorry.
No, go ahead.
I guess like one of the things I tried like near the deadline was to try different CV strategy. Is I tried to make the strategy even more strict by grouping on the topics, but well, because I was thinking if I were to design the competition, I mean, surely it would be more useful if the model could generalize to unseen topics, right? Because like essays from classrooms, they always come in groups. But it's just like there might be essays on different topics, right? The students might be asked to write on different topics. But I think in this case, it doesn't really apply. I think the topics overlap between the training set and the test set. Yeah, so I mean that didn't really improve anything. And also for some reason I think stratified k-fold is, I mean, it works well in this case, right? As compared to a group k-fold.
Yeah, that's the thing we discussed last week as well, right? Like even though strictly speaking, stratified group k-fold is the thing that should use because otherwise there's leakage across essays and stuff. And I get the details now, but there is some leakage if you just stick to stratified K versus stratified group based on, I think, the essays as well. But what people have observed is, at least with respect to the the public leaderboard, they were getting better scores, even though the CV results didn't correlate the leaderboard results if you use stratified k-fold. So stratified k-fold, your CV didn't track leaderboard results, but people who use stratified k-fold said they got better. If they use stratified group k-fold, it correlate, the CV results correlated, but the models picked didn't, which mentioned last week. I don't quite get why that's the case and explanation why that's the case in this competition.
I guess, well, I guess as long as the topics that are in the training set are also in the test set, it doesn't really matter if it doesn't really matter whether the discourse comes from this essay or that essay. Yeah, like, yeah, the essay where the discourse comes from is it's not important to whether, well, I guess, yeah, I don't know. Yeah, I'm not sure.
Yeah, I haven't sat and thought to the whole sequence of events which would make what we are observing make sense. So as you're saying, right, like because the disadvantage of stratified K only versus the group is what you said, I think.
Yeah, and I guess also like
essay.
Like an essay would only have a very small number of discourses of the same type, right? So, yeah, so chances are, even if you're using stratified Kaggle, you probably won't have many instances where discourses of the same type appear in your training split and your validation split. That's my guess. Like say if you only have let's say if you only have like one conclusion and an essay, then this conclusion will appear in either the training split or the validation split, right? You won't get like a conclusion in both the train split and the validation split. So in that sense, the situation is the same as if you would be using group K-fold.
Yeah, that's something I have to think about.
Yeah. Anyway, how did you guys do that?
I combined, as I was saying last time, the predictions using the topic labeling or sort of labeling of topics of the prior competition, using somebody's pre-trained Liberta V3 large model that he had done that with. And then there was this gigantic ensemble of 4 models, each with multiple folds that Mayank had pointed to. So I just picked specific, there's a Liberta V3 large model that was available that had been trained on topics. And then a Liberta large model from the big ensemble that was just generic. It didn't use the topic and just did standard combination. And I just combined them, gave them roughly equal weights. I tried a bunch of slightly different weights and stuff. And I ended up actually fairly good scores. So I ended up with a bronze, around 139. And that was just combination of 2 Liberta, one Liberta large and another Liberta V3 large. Each of them with one of them with 4 and another one with 5 folds, and averaging them with roughly equal weights. In fact, it turned out that I had slightly overweighted the topic one, and that was one of the model choices. And if I hadn't done that and I had equal weights, that one gave, actually I didn't pick it, but it gave a little bit better, but my position wouldn't have changed because the scores fell in a range where I was by myself, and it was around 0.600. That's where I ended up.
Did you include any XG boosts or Roberta?
No, that was there in the model that Mayank had pointed to. There was XG boost, there was Roberta, and I kind of played around with it and dropped Roberta, dropped XG boost, dropped a Roberta base, which was also included in that, and it didn't seem to necessarily. In fact, my model kept getting better. So once I included the topic modeling, that one, so 2 Roberta base models, 2 Roberta large models, one without topic modeling, Roberta large, and the one with topic modeling, Roberta V3 large, that alone seemed to matter. And the combination of the two got me into the 130s of range and score of around 0.6. In fact, interestingly, my score, the other interesting thing I observed was my score on the public leaderboard was actually little worse, and I jumped up not by much, but about half a dozen or so positions, like 4 positions or so. I went up when trained on both the or when the results were published on both the public and the private leaderboard. So my public leaderboard scores were a little lower than what eventually my private leaderboard scores. Interesting that it actually performed better. Slightly, not by much,
like,
but
yeah, I think when you use ensembles, like the score tend to jump up, like because you're less likely to overfit. So those people who overfit, they drop down, and then because your ensemble generator is better, it moves up. It's kind of like I think
yeah, but
that
the
happens like
thing with,
in general.
yeah, you're right. But the thing that surprised me, which was interesting, was typically, if the thing, and what it told me is these models seem to be correlated because typically the more different uncorrelated models that you ensemble, as you said, the generalization effects are better and you tend to not overfit and your score improves. But in this case, in playing around with it, which is all I did towards the end, I found that dropping a bunch of models actually didn't have, and not just didn't have, it actually improved my score. The big jump I got was by including the topic-oriented prediction model with Liberta V3 large, which the guy had trained, and using that in combination with the Liberta V3 large model that was there in the huge ensemble mine pointed to just the two of them were worked out better, and I could safely drop but the XGBoost, the Roberta, and all these other models that had also, and there was another, there were 2 Liberta large that he was actually. So I dropped all of that and it turned out, actually my performance kept improving even as I dropped that. So, or at least it didn't degrade. So I was like, hey, let's go with the simplest combination. But the other thing I noticed, obviously, if you look at the results, and then I also bookmarked, and I can hear that the whole lot of, if you can see my screen.
Yeah, I can see your screen.
Yeah, so this guy who's he was the same guy who posted this Liberta V3 large with topic modeling. And he, as you can see, he ended up in 67th place, but there's a lot of, he just combined the best solutions. I haven't had the time or yet to go through, but it seems like some of the models are fairly simple. In fact, that the one of them, from what I saw, was I forget which one it is, but one of these is the Thakur guy that you had, his earlier versions or something that you had attempted to duplicate, if I recall.
Yeah, I couldn't. Unfortunately I couldn't repeat what he did. So
yeah, no,
but I know. Yeah,
he
I've noticed
subsequently has made. Yeah, go ahead.
Go ahead.
He had subsequently made some more changes, I think, and I forget which one is his. The where he ended up, but I wanted to, there seems to be this seemingly are simple single model solutions that, like this 80th place solution that you see. Then here it says my single model experiment log continued getting to leaderboard of 0.588 with 5 folds. I think, and then how to train divert and NLP tricks. So I want to kind of spend some time because it seems like it's quite a bit of simple things that people have done that really gives results. So, and then, the two things that frustrated me because I was unable to do it in time, and it seems to have mattered quite a bit in this competition. I think the first place or one of these top guys, as I said, I just briefly scanned, but I would say going through many of these in detail and looking at them, maybe even, we should do that because it's worthwhile as to what really worked and what didn't, and the various tricks. But the two tricks that I was aware of and we have discussed, but I wasn't able to implement in time. So I want to spend some time looking at the notebooks which I've successfully implemented and at least make it part of my repertoire of tricks to implement for NLP going forward. Is one is AWP, this augmented whatever way the thing we discussed. That seems to have been implemented. Sorry.
So have you noticed people mentioning that AWP helps a lot in this competition?
Yeah. Okay. Yeah, I've seen it at least in a couple of notebooks that they've said, oh, look, we were kind of stuck at this point around where I'm stuck, right? Like even though I got a bronze, it's at 0.600, but people who dropped to 0.58, 0.56, 0.57, I think again, and the other thing I would comment is I think the other observation I would have is it seems like in this competition at least a lot of different techniques worked. Not everybody did the same thing. Different people tried different things, and it seems like the different things work. So I want to kind of, it's a good competition to build up your skills of doing different things. So I saw at least a couple of notebooks that seem to suggest that the adversarial weight perturbation seems to help. Similarly, the other thing which I tried, but as I said, I ran into my own inability to implement it successfully. So I want to kind of stick with it and learn from this is one, the AWP and how to implement it in any given situation in NLP. And then the second thing is the thing that I think that you may have pointed, or even I might have pointed back, but I in fact tried it, but I couldn't get the right implementation to work in inference, which is this embedding the discourse type within the essay. It's within the essays, and then using that to do the prediction. And a couple of these notebooks, which have ended up fairly high, I don't know, let's say top 100 or top 75 or something like this. I saw a couple of them use that technique as well, which is I had proposed, and I even got the training part working, but I was, stuck in inference successfully, and that seems to have made a difference. Those were the two things that at least I was aware of before the competition ended that I didn't successfully implement, if you will. But it seems like if I had implemented those in combination with what I was already doing, then that would have bounced me up even more significantly and got me, in fact, I was stuck at this 0.600. And if I wanted to get with a, 0.5xx as my result, whatever the first digit being 0.5, then I needed to have done at least one of the two or both. So
I
I would
saw that
say, you know,
the competition
sorry, go ahead.
hosts mentioned that there will be a third feedback competition, which will be the final one in this series. So I guess you can, yeah, I guess you can try these techniques in the third one, right?
Yeah, at least, you know, become smart about it where I can implement those and be ready
Just
next
throw everything
one.
in like for the third one. But I noticed like the top solution, they do the thing where each sample is one essay, and then they just pull over it like the different discourse types, and then make predictions for all of them at once. And so they mention that for them that really improved the score as well as their model's efficiency.
Sorry, could you repeat that? What are you saying? So this one you're talking about? Should I?
Yeah,
that?
you know the one where like you have the entire essay and you indicate where like a lead starts and ends, where like a conclusion starts and ends, and then just process the whole essay in one go.
So
That's the
that's
one.
the
That's the
model I
technique
was
they
talking
used.
about of embedding the
Yeah,
discourse type in the essay.
yeah.
Okay.
And so yeah, you can. That's the example there. You can see it's like the entire essay, and they just process that. And
Yeah, and
that's what
also
they,
you see your technique is used by them.
yeah, like to predict the type. Yeah, to I think they tried several variations, and one of them was to predict the type of the discourse.
I see.
Yeah.
And you know, I hadn't thought of this, but or at least if in the explanation we were discussing, it's interesting that they claim that this is a benefit, which is, I guess, just another way of saying it generalizes better, right? Because when you regularize the model, all you're saying is it generalizes better. But me, the regularization also says that you're doing something, the loss surface or where you are in the loss surface, because if we are in a flatter region, you're trying to get to a flatter region by regularizing the model, right? I mean, that's at least my mental concept of regularization, which is what they say is happening by adding this additional auxiliary loss.
Okay.
But
Yeah,
they
I
don't
mean,
combine the two though. It's interesting. They say an additional sub approach does not have this auxiliary loss and trains a model based on the following output. So I don't know. Yeah, I have to read this to see which of the approaches they
no,
eventually used or a combination of whatever.
the difference is like if you see the current example for the start token, you have you indicate the type,
Yes.
but in the above example, you leave out the type. That's the difference between
Right.
these two.
Yeah, the one
Also,
I tried
they
to
did a lot of
implement,
pseudo
it
labeling.
didn't. Sorry.
They also did pseudo labeling.
Interesting.
I think so.
And
This is what is called pseudo labeling, adding start and end tokens in the beginning and the end of each topic of the each essay.
no, he's saying, Jack is saying you see, I scroll down and they have separate discussion on pseudo labeling.
Okay.
So they use the previous competition's data and label that. So actually, what they did was they trained several data large, so they have a quite large ensemble. And so if you have a large ensemble when you're doing the inference, it takes more time, right? So they actually use that ensemble to pseudo label the data from the previous competition. And because it's an ensemble, they will give you like the best pseudo labels, right? So they then trained just a single delta large on the pseudo labels. And then for submission, they just submitted this single delta large. And it has like the best performance and the best efficiency. So that was pretty,
that was something I was
clever.
blown away by. Yeah, that was
Yeah.
very impressive because they did the prediction, like I think, Jack, you had spent some time looking at how much time the models took, and you had, like, I think, shared, you were able to get yours to what, 20 minutes or something, if I recall correctly, somewhere in that range?
Yeah. So there is 5 minutes, right?
Yeah, I saw that. They had gotten it down to 5 minutes, and I was like, wow, this is worth studying of what they did. And what you're saying is they if I
didn't
understand you
submit an
correctly,
ensemble.
let me repeat to myself. I'll get into the details by going through the notebook. But what you seem to say was that they trained on a larger data set, which is the data set of the prior competition and the current one, all the essays put together, and then they trained an ensemble of models, and they used that ensemble to predict. Now, did they use that to predict the discourse type or the effectiveness? Generate the pseudo label for?
No, like, so by training on the data of the current competition, they produced a very large ensemble, and then they use this large ensemble to label the data of the previous competition. Then they gather together the pseudo labeled data and the labeled data from the current competition, and then they trained just a single delta large model, which is the one that they submitted. Yeah.
Right, because the prior competition did not have labels for effectiveness. So that makes sense. So what they did,
Correct,
because the prior competition was one where you just predicted the discourse type. So, it did not have effectiveness. So what you're saying, to repeat, so I recall this correctly, is that they used the current label model, created a large ensemble, use that ensemble to create pseudo labels for the prior competition data, which data-wise, that's a larger data set, and combined all of the data, the pseudo labeled one of the prior and the current labeled one, trained a single large data model on it, and that became their final model.
Yeah, they say that single model is good enough for the top 3, to achieve top 3 on the accuracy leaderboard. And obviously, they also finished first in efficiency.
Right, very interesting.
That's
where I was saying that. Go ahead, Mike.
Yeah, I was thinking, is this acceptable with respect to using the previous competition's data to make your model ensemble good? Is this acceptable from the?
Yes, they it depends on the competition, but in this competition, no, they didn't prevent. In fact, even I'm doing that because I'm using the topic modeling that I mentioned uses data from and uses pseudo labeling of the previous competitions data because it uses the topic modeling stuff.
All right. Okay. So you are using previous competitions data in your final submission.
Yes.
Okay, that's interesting. No, like yes, for this competition, the host explicitly mentioned in the data description that the data for this competition is a subset of the data from the previous competition, and please feel free to use that as well. And so yeah, so
Right.
it's allowed.
Right. Yeah, exactly. Sometimes the competitors, the competition host tells you whether or not, and in this case, you are allowed to, whether or not you're allowed to use external data or prior data. And in this case, they explicitly said you could. And in general, even competitions that restrict usage, typically in Kaggle, what they tell you is if you're using external data, as long as you make the data public or the data is itself public, you're allowed. There are very few competitions, at least that I'm aware of, where they completely restrict usage of any other public data. What typically happens is they say, if you use any data other than that provided by us, that should either be already public, so anybody can use it, or if you have some access that nobody else can, then if you make it public by making it a data set or whatever, or pointing to it and saying, hey, here's data set that's public now, then you can go ahead and use it. That's typically what I've seen.
But do you have to explicitly tell others that, oh yeah, there's this extra data set, by the way, or can you kind of just not mention it?
No, you can, you can use it if it is already public. If it's public and nobody restricts usage of it, then you don't need to do anything. But let's say you're a member of some organization, and that organization is what enables you to utilize membership in that organization. For example, like I don't know, you're a doctor and they have this medical competition, and you're a member of the radiology department, and the radiology department has a bunch of X-rays, and that's something that you're using, which you alone are using because of your ability to access that data. That's a no-no unless you make that data publicly available as well. So basically, they want to level the playing field for everyone, right? You can use data provided the data can be used by every other competitor.
Yeah.
That's kind of what I've seen in most cases.
Okay, thanks.
And in this case, like you were saying, Jack, the trick or the additional thing you had to do if you are using the prior competition, because the prior competition data exists, but you absolutely needed to do, you absolutely needed to do the pseudo labeling, because as I mentioned, the prior competition was discourse type prediction. So it did not have any concept or did not have this effectiveness as part of the data. So that's the reason why, and in the case of the guy doing the topic stuff, he used it for the topic modeling aspect, like, to say which of the essays are on which topic. And as I mentioned in one of the prior discussions, the conjecture was that the reason the topic modeling helps because it again helps, much like this auxiliary loss, it tells the model something about the if the effectiveness of the arguments, because the topics seem to vary depending on the grade level, and certain topics seem to be more assigned to grade levels where you see maybe a distribution different in the effectiveness. The effectiveness distribution of essays for higher grade levels is different than for lower grade levels, and that was the conjecture that why topics seem to help the model. If you give it this additional knowledge about topics, the model somehow is able to figure out, oh, if these are the topics, then the distribution of effectiveness is skewed in this way or that way compared to the lower grade level. I mean, this is all a conjecture, but that's the reason why you see better results. You see adding the topic model on top of the regular model. Just like the auxiliary loss, right, is helping the model somehow figure out that, oh, if it's of viscous type this, then I'm going to do, it helps me do a better job for the lower frequency.
Yeah. So are you saying like you want to spend some time going over these top solutions?
Yeah, if
like maybe next week
if
want to
people
have
are
a
interested, at least we can spend one more week if any of you want to, take up a couple of these examples and kind of at least look through them in more detail. I haven't had the time to do it, but if you wanted to do that, I would be open to that. Spend another week, like, if each of us takes 1 or 2 notebooks and goes through it in some detail and says, oh, these are the techniques they are using, this is what they attribute, these are the score, this is what helps them, and stuff like that. And, that would be, I thought, helpful. If you and Mayank are interested, we could do that. See, we can do that right now, but, without having already gone through it, I think it'll just be just a lot of time circling, but I think it'd be more efficient if we do it offline and then we're able to go through a couple of the notebooks, each of us.
Okay.
That might be interesting thing to do, to learn from this, and especially if there is a third competition, then the investment may not be wasted. We may be able to do something better in the next one.
Well, maybe the third competition will be on a completely different task. Well, none of these techniques will be.
No, but I mean, similarity of some techniques are, like this AWP, like the embedding and kind of using the -100 for the inference and, for blocking some of the token. Those kind of techniques I'm seeing are very generic and applicable broadly, right? Like I wish I had learned AWP from the prior competition, which is what Steve was trying to do by getting it implemented and stuff. And if I had that, then I could have used it in this competition, but I didn't. So I think in that sense, some of these techniques are generic. So that was something I was thinking of. And if you guys are up for it, I'll definitely spend my time this week. The other thing before we go off is, I think, time to think about also which next competition. There are several that have shown up, I think, recently in terms of competition, which may all be interesting. So, some time looking at which of these would be of potential interest going forward. And some of them are ending. They're only a month to go. So while they may be interesting, a month is shorter time, at least in the kind of structure we have. But some of the other ones, like this has 2 months. There's one which I think just opened up this one. 3 months to go. Some of these 2, 3, 2 are the potential ones that would be interesting.
There's one on football, right? Bundesliga.
Yes, this one,
Okay.
right?
Yeah.
That has about a couple of months, so it's only ends in October, middle of October, so that'll be interesting. There's this cell one that's has 3 months to go. There's also the cervical spine detection, which has 2 months. There's a horse race prediction. I don't know whether this is tabular or what.
Yeah, it sounds interesting.
Completely different. Horse betting. And then this seems to be multimodal, which means I would imagine that it is image and text, but I may be wrong. So anyway, spend a few minutes looking at these and thinking what might be interesting or what sparks your interest. I would rather we pick things that people are actually vested and interested in doing something, because and I'm typically, people have suggestions, but if they aren't going to participate or contribute to discussion, then it makes it harder. And so I kind of tend to weight the inputs of people who participate regularly higher. So let your thoughts, and you can post in Slack as well. And if you folks are up for it, I think, like I mentioned, I'll definitely look at a couple of these notebooks. And you can pick and choose whichever ones. Even if we end up picking the same one, that's okay. It's kind of more a discussion and learning the things. At least I want to pick one that probably has AWP in it. Just so if they explain that, I might end up picking one that does it. Post something in Slack if you are choosing a particular one and you want others to once. And feel free. It doesn't mean you have to only talk to that. If you have scanned all of these and have some comments on multiple of those, that's fine too.
Okay.
Yep.
And typically in the past, we have kind of done that where, relevant papers or relevant techniques, we spend a week or two discussing, because otherwise, in the throes of the competition, you're limited by time and what you try and all that. Where this is a phase where you learn from the results and you kind of learn to apply it and try it on your own. So I think that serves a very useful purpose, I think. If you folks are up for it, then that would be a good thing we can do. So Mayank, were you able to submit anything? And
Yeah, I followed on the last week's submission. Yeah, got around the same score that I had. Wasn't able to add much to the new ensemble that I was trying to create. It basically it was the solution that had the same notebooks and how do I say it? The techniques which I was trying to implement, but due to some time limitations, I wasn't able to add much to that. But yeah, I'm currently I was satisfied with what I had built up. Next week we will give it a try on having the top solutions and how do we go about getting more from this list of top solutions, and what all techniques that they have applied, the top Kagglers have applied to their own solutions.
All right. Cool. Thanks for joining, everybody, and hope we'll see you next week, and we'll spend some time discussing these solution details. If you can pick and choose, as many as you would like, and talk to them, and what you found interesting, or what you couldn't understand, or what you would do differently, or combinations, or whatever. And the same, I'll try and pick a couple and do the same as well. And then post any suggestions for new competitions that strike your interest. And in a week or two, we'll new competition and spend some time on that going forward.
Cool. Thanks.
Thank you. Thanks, Jack. See you.
Cheers later.